Okay, so this video tutorial will aid you in your quest for knowledge about work and power. Okay, so let's dive right in and let's look at work, for example. There are two definitions of work. Work is your force parallel to your displacement times that displacement, or work is your change in kinetic energy. Now, by change in kinetic energy, I mean Ke2 minus Ke1, or the final kinetic energy minus your initial kinetic energy. Okay, so let's say you've got a problem where you've got a guy and he's pushing something and he's pushing it with a force of, let's say, 50 newtons. Okay? And let's say he pushes this object 5 meters, and I want to know how much work is done by the worker on the wheelbarrow. Well, how much work is done, if you think about it, you've got the force parallel, it's 50 newtons, and you've got your delta x. So the work in this case would just be 50 newtons times 5 meters. Well, work is going to be 50 times 5, so that's 250, and the units on work are joules. Okay? So, simple, straightforward problem that deals with work. Let's look at, let's see. Let's look at a problem where you've got a guy and he is pushing against, with super long arms, he's pushing against this 1-ton thing. And let's say he's pushing with a force of 10,000 newtons. Not realistic, but let's just say for x he is. But the object doesn't move. Okay? So in order for work to be done, you first have to have some force, but you also have to have a displacement. So in this case, there is no work done on this object. Okay? So in order for work to be done, you must have a displacement and you must have a force. Okay, so let's say I ask you how much work is required. So we're looking for work to lift, let's say it's a 10 Newton weight. So I don't give you the mass, but I tell you that the force due to gravity is 10 newtons. Okay? And you lift it from a height of 4 meters to a height of 40 meters. And I want to know the work done to get there. Well, you've got to be lifting this block up. Now, nowhere in this problem did I mention that there is an acceleration. Okay? So you have to assume that the acceleration is 0. In other words, I'm lifting at a constant speed. So I've got the force due to gravity down there. It is 10, and I've got my force due to lift, and it is also going to be 10. Now, one of these needs to be negative, so I would make force due to gravity negative because it's going down. So you've got your lift force to be 10, and they want to know how much work it takes to lift this object. Well, that means they want to know the work done by the lifting force. So what you do there is plug in your lift force for the force parallel, and you multiply that by your displacement. In this case, it's going to be delta y. So the work would be 10 times the displacement is going to be 36. So the work done by my lift force would be 360 joules. Now, how much work would be done by gravity? Well, if you think about it, if your acceleration is 0, that means that there is no change in speed. Well, you think about work as the change in kinetic energy, so if there's no change in speed, the total work done here is 0. So that means that the work done by gravity has got to be negative 360 joules. Okay? So, when they ask you for how much work is required to lift an object, that means how much work is done by the lifting force. Okay? Now, let's say you've got a 50 Newton object. So force due to gravity is negative 50 newtons. And let's say let's say you do the work done by your lifting force is let's say 250 joules. Okay, so you've obviously got a lift force here. And they want to know what distance did you lift that object. Okay? Well, you've got work, and you've got the force, because if you think about it, nowhere in there, again, does it mention acceleration. So that means that this lift force equals the force due to gravity, but it is opposite. So that means that the work done by the lift force is, again, the force lift times my displacement. Well, I'm looking for the displacement, so that means that 250 equals 50 delta y. So if I divide both sides by 50, I get a delta y of 5 meters. Okay, so you can go the other way with it. All of these problems, you're going to have everything except one variable generally. Okay, you have to know which equation to solve for. Okay? So, that is, let's see, that is work. Okay? So, let's talk about power. So, let me clear this real quick. Okay, so power is given to us as the work over time. So really, power is the rate of work. Okay, so the units on power, this gets confusing because the units on power, work is in joules, time is in seconds. Well, that is a watt, which is abbreviated capital W, which is the same as work. So it looks like it's watts over time, but it's really work over time. So a watt is joules per second. Okay, so if you think about it, when we think about power, we think about a motor or something that's doing work. Okay, so the more powerful a motor is, basically it can do work in less time. So think about it, if you had two motors and they both do the same amount of work, but one does it in a lower time, so in other words a number that is lower than t, then the one that does the work in less time is more powerful. Because if you think about it, power is given by this division. Well, if you've got a lower number on bottom, a number divided by a lower number, it gives you a bigger number. If you think about it, 10 divided by 5 gives you 2. Well, 10 divided by 2 gives you 5. The lower number on bottom gives you a bigger number overall. Okay, so let's look at an example here. Let's say we've got let's say I've got an elevator. Okay, and the elevator, its force due to gravity, in other words, it's a let's go 1.81 times 10 to the fourth newtons. Okay? So when I say it's a 1.81 times 10 to the fourth Newton elevator, that means that's what force due to gravity is. Okay? Now, let's say I want to lift this elevator. I want to lift the elevator 12 meters, and I want to do it in a time of 22.5 seconds. Okay, and so they want to know what power motor would be necessary to do this. Okay, so this leads us to our other definition of power, which is our force times our velocity. Okay, so if the force due to gravity is this, that means that my lift force, in other words, the force that the motor is providing, is positive 1.81 times 10 to the fourth newtons. So I've got my force, but now I need to know what my velocity is. Okay? To get that, I'm going to use divot. Distance equals velocity times time. I know my distance, it is 12. And I know my time, it is 22.5. So I am going to divide both sides by 22.5. Whoops. To get a velocity of 5.333333333. So we'll just go 2 3s. And that is in meters per second. So now take that, plug it in for velocity, and take my force, which is 1.81 times 10 to the fourth newtons times 5.33333. So 1.81 e to the fourth gives me a power of 9,000. It's a big one. 9,653, and the unit on power is watts. Now, scientific notation of this, if I move this decimal over 1, 2, 3, it becomes 9.65 times 10 to the third. I just dropped 3 because we'll just go with 3 sig figs. Watts. Okay? So, that would be an example of power, needing to find how much power is necessary in order to complete a job. Okay, so let's look at one more, shall we? Let's say let's say I ask you what the units on power are. All the possible units. Well, you know you've got a watt. Well, a watt is a joule per second. And there's one more that we didn't really talk about, but I'm going to tell you, video watchers, now. It is horsepower. Horsepower is a type of power, hence the P for power. So, those are the 3 units that are acceptable for power. Don't forget that. Very important. So, that is work and power.